Welcome, my friends! Today we will be discussing the hypothesis test for two independent population proportions using the TI-84 calculator. The goal of the two-sample proportion test is to determine if the proportion from population 1 is greater than, less than, or different from the proportion of population 2. For a left-tail test, we believe the first population proportion is smaller than the second, indicated by a less than sign in the alternative hypothesis, and the p-value is in the left tail of the distribution. For a right-tail test, we believe the first population proportion is greater than the second, indicated by a greater than sign in the alternative hypothesis, and the p-value is in the right tail of the distribution. For a two-tailed test, we believe there is a difference between the two population proportions, but we aren't sure which one is larger, indicated by a not equal to sign in the alternative hypothesis, and the p-value is the combined area in both tails. Let's go over the assumptions of the hypothesis test for two independent population proportions. There needs to be a binary, categorical variable gathered from two independent groups. By binary and categorical, I mean there are two non-numeric outcomes, such as yes or no, success or failure, agree or disagree, or some other similar pair of two outcomes. Second, a random sample must be used to gather the data from both populations. There's also a condition to ensure that the distribution of the difference in sample proportions, p-1 minus p-2, follows a normal distribution, but you have to do a lot of calculations to check this condition. It's super tedious, so I'm not going to be checking it in this video, but if you're curious, I checked this condition in my two-sample proportion hypothesis test by hand video, linked in the description. Since we are using the z-distribution for this test, the test statistic will be a z-score. Here is what the formula looks like for the z-test statistic. We won't have to calculate this value since we'll be using the TI-84 calculator, but this is what the calculator uses. Note that p-bar and q-bar are the pooled proportions of successes and failures. They are just p-hat and q-hat if all the data was assumed to come from a single sample. Once again, we don't really have to worry about that since we're just going to be using the calculator. Let's look at an example. Do college-educated adults read more than adults without a college education? 190 randomly selected adults with a bachelor's degree or higher and 210 randomly selected adults without a college degree were asked if they had read a book within the last month. Of the college-educated, 95 had read a book in the last month, and of the non-college educated, 84 had read a book in the last month. Is there sufficient evidence to suggest that the proportion of college-educated adults who read is higher than that of non-college educated adults? Use a 0.01 level of significance. Let's start by writing out some of the given information. We can let sample 1 represent college-educated adults, and sample 2 represent adults who do not have a college degree. X1 is the number of successes from sample 1, which is the 95 college-educated adults who read a book in the last month. And X2 is the number of successes from sample 2, which is the 84 non-college educated adults who read a book in the last month. N1 is the 190 college-educated adults surveyed, and N2 is the 210 non-college educated adults surveyed. We don't need to calculate p-1 or p-2, as the calculator does that for us. But if we wanted to, we could take 95 and divide by 190 to find p-1, and take 84 and divide by 210 to find p-2. Let's go through the 3 steps of the hypothesis test. Step 1. The null and alternative hypotheses. For the difference of two population proportions, the null and alternative hypotheses contain p1 and p2 with some symbol in the middle, which we will determine based on the wording in the problem. In our case, we notice that the question is asking if the proportion of college-educated adults who read is higher than that of non-college educated adults. This is equivalent to asking if p1 is greater than p2, which becomes our alternative hypothesis, the proposition we would like to research or prove as part of our hypothesis testing procedure. The null hypothesis always contains an equal to sign, so we have p1 is equal to p2 for the null hypothesis. Step 2. Calculations. In this step, we get to go to the TI-84 calculator. Press Stat, and arrow over to the right twice to get to Tests. Scroll down to 2prop-z-test and press Enter. Now enter in the statistics we wrote down from earlier. X1 is 95, N1 is 190, X2 is 84, and N2 is 210. This part is just asking for the alternative hypothesis, which is that P1 is greater than P2, so select the last option. Arrow down to calculate and press enter, and you will have the output we need for this hypothesis test. We see the test statistic is about 2.01 and the p-value is 0.0223. If we want, we can graph the distribution and shade the p-value in the right tail of the distribution. Step 3. Decision and conclusion. If the p-value is less than or equal to the level of significance alpha, then we reject the null hypothesis, and if the p-value is greater than the level of significance, we fail to reject the null hypothesis. Like I always say, if the p-value is low, the null has to go, and if the p-value is high, the null will fly. In our case, the level of significance is 0.01, and the 0.0223 p-value is greater than the 0.01 level of significance. The p-value is greater than the level of significance, so we fail to reject the null hypothesis. The p-value is high, so the null will fly. Our conclusion is that, at the 1% level of significance, there is not enough evidence to suggest that the proportion of college-educated adults who read a book in the last month is higher than that of non-college-educated adults. And we are done. Alright, my friends. That wraps up our discussion of the hypothesis test for two independent population proportions on the TI-84. We will be exploring many more fun and exciting statistical topics, so make sure to check out our other videos.